The goal is to expand a single logarithm into multiple logarithms. We are going to use the power, product, or quotient rule for logarithms to expand a logarithm as much as we can until they can no longer be used. These rules at the bottom will be brought in when needed, but the main focus will be working with the power, product, and quotient rules for all of our examples. To whet the palate, let's go ahead and do a simple example using each of these rules, starting with the power rule. Consider log base 5 of z to the 7th power. The power rule up top tells us that if everything within our logarithm is raised to the power r, we can bring the power r out front and leave everything else inside. Down here, everything within our logarithm is raised to the 7th power, so we can bring 7 out front of the logarithm and leave z inside. For more context on the logarithmic power rule, check out this video here. Now, a quick example using the logarithmic product rule. Consider log base 10 of x times the quantity y plus 1. The logarithmic product rule allows us to rewrite a product of two expressions as the sum of two separate logarithms, each containing one of the two expressions. Within our logarithm down here, we have x times the quantity y plus 1. We have a product of x and y plus 1. Using the logarithmic product rule, we can rewrite this single logarithm as the sum of two logarithms with the same base 10. The first logarithm containing x and the second logarithm containing y plus 1. For more context on the logarithmic product rule, check out this video here. Next, a quick example using the logarithmic quotient rule. Consider natural log of z divided by 100. The logarithmic quotient rule allows us to rewrite a single logarithm that contains the division of two expressions as the difference between the logarithm containing the numerator expression minus the logarithm containing the denominator expression. Down here, the expression in our numerator is z and the expression in our denominator is 100. Using the logarithmic quotient rule, I can rewrite natural log of z divided by 100 as natural log of the numerator expression, z, minus natural log of the denominator expression, 100. For more context on the logarithmic quotient rule, check out this video here. Now that we've warmed up using one rule at a time, we are going to work through some problems that expand a single logarithm using two of the rules at a time. Consider our first problem, log base 2 of x times z to the 5th power. We scan the inside of our logarithm, and I see the product of two variables, so we may be using the product rule. One of the expressions in our product has the power of 5, so I think we may need the power rule as well. Now, should I handle the product or the power first? Well, that would depend on the problem. But in order to use the power rule, everything within the logarithm must be raised to the power to bring it out front. Since we are not working with x times z all raised to the 5th power, we will not work with the power rule first. So we'll start with the product rule. I have a product of x times z to the 5th power. I can rewrite this single logarithm as log base 2 of x, the first expression, plus log base 2 of z to the 5th power, the second expression. At this stage, we look within each individual logarithm on the right-hand side to see if we can use another rule to expand it more. Well, log base 2 of x is as simple as it can get, so we bring it down as it is. Looking at log base 2 of z to the 5th power, I see everything within our logarithm is raised to the 5th power. So I can bring the 5 out front using the logarithmic power rule and keep everything as is on the inside. At this stage, I look within each one of my logarithms and I think about whether I could use a rule to simplify or expand it more. It seems like I can't at this point, so I've expanded log base 2 of x times z to the 5th power to the best of my ability. Let's move on to another example. Consider log base 6 of the quantity x plus 1 raised to the 4th power all divided by z to the 3rd power. I see division between two expressions, so I know I'll need my logarithmic quotient rule. Each of my expressions are raised to powers, so there is a good chance I may need my logarithmic power rule. Scanning the inside of the logarithm, is everything on the inside grouped together and raised to the same power? No. So I will not use the power rule first. Let's use the quotient rule. We can rewrite this as log base 6 of the numerator expression x plus 1 all raised to the 4th power minus log base 6 of z to the 3rd power. Now, we look within each of our individual logarithms on the right-hand side to see what rules can be used to continue to expand the logarithms. Looks like within both logarithms, everything on the inside is raised to a power. So we could bring the power out front and then leave everything within the logarithm as it is. At this point, there is no other rule I could use within this expanded form, and so I am done. Next, we got some math. Here is the first problem that will require us to use all three of our main rules to expand it fully. Alright, let's scan the inside of our logarithm and see what we should do first. What do you notice about this problem that is different than any of the others we have gone over so far? Well, I have everything within my logarithm raised to the second power. Here, since everything within the logarithm is grouped together and raised to a power, we can use the power rule first. Using the power rule, we bring the 2 out front and we leave everything on the inside as it is. Next, since I have the division of 2 expressions, I'll use the logarithmic quotient rule. I can rewrite my logarithm as natural log of the expression in the numerator, m times a, minus natural log of the expression in the denominator, t times h. I have to be sure to bring down the 2, which is multiplied by everything. Looking at natural log of m times a and natural log of t times h, I can use the logarithmic product rule to break up the product of the 2 variables within each one of these logarithms. I can rewrite natural log of m times a as natural log of m plus natural log of a. I can rewrite natural log of t times h as natural log of t plus natural log of h. Now here, I must keep these within parentheses to ensure that the negative symbol is distributed into both. I can also distribute the negative symbol into both logarithms and have negative natural log of t minus natural log of h. Remember, I have been carrying this 2 multiplied by everything down since the beginning, which can also be distributed to all terms, and it gives us this form. Now, to me, all 3 of these lines are sufficient as a final answer. They all represent the same thing. But I am not your teacher, so make sure you read the directions to see what is required in the final expanded form. Moving on to another problem. Consider log base 3 of 3 cubed times the quantity y plus 3 raised to the second power all over z to the third power times x. We scan the logarithm. Is everything on the inside grouped together and raised to the same power? No, so we won't be starting with the power rule. I see I am dividing 2 larger expressions, so let's use the quotient rule first. We can rewrite this as log base 3 of the numerator expression minus log base 3 of the denominator expression. We don't see everything on the inside raised to the same power in either of these logarithms, so we handle products of expressions next. 3 cubed and y plus 3 to the second are my 2 expressions in my first logarithm. So I can rewrite that as log base 3 of 3 to the third power plus log base 3 of the quantity y plus 3 squared. Similarly, I can rewrite log base 3 of z cubed times x as log base 3 of z cubed plus log base 3 of x. Be sure to put the parentheses around these until we distribute the minus sign. Looking at log base 3 of 3 to the third power, there is an inverse rule we can use here specifically for when the base value being raised to a power matches the base of the logarithm. When the base of the logarithm and the base of the exponent within the logarithm match, we can replace everything with the power of the expression inside the logarithm. So we can replace log base 3 of 3 cubed with just 3 using the inverse rule. We can bring everything else down as it is. Finally, we handle the powers within each of the logarithms. I can bring the 2 out front here, and I can bring the 3 out front here. Everything else comes down as it is. Within each one of these logarithms, there is no other rule I can use to continue expanding, and so I am done. For an alternate form of the final answer, I can distribute the minus sign in here and get this result. But to me, getting to either of these 2 final forms demonstrates to me that you know how to use the logarithmic rules to expand logarithms. Let's move on to the boss log. We begin by scanning the logarithm. How do we handle square or cubed roots within our logarithms? Well, we can convert back and forth between the radical form and the fractional form of these powers using this guide right here. So we have the square root of x minus 2. The value of n here is 2 for the square root, and the power under the radical is 1, so I can rewrite this as x minus 2 raised to the 1/2 power. Down here we have the third root of y to the 5th power. Using this guide, we can rewrite this as y to the 5/3 power. Well, this may not look nice, but we end up working with fractional powers the exact same way that we have been working with integer powers in all of our other problems. So let's just move on to expanding the logarithm. I encourage you to expand this one on your own first, but in this video we wait for no one. Is everything on the inside grouped together and raised to the same power? No. Alright, so let's use the quotient rule first. We can rewrite this as log base 5 of the numerator expression minus log base 5 of the denominator expression. Within each of these logarithms, I have a product of two expressions. In our first logarithm, 5 and the quantity of x minus 2 raised to the 1/2 power are the two expressions. We can rewrite this as log base 5 of 5 plus log base 5 of the quantity x minus 2 all raised to the 1/2 power. We can also rewrite our second logarithm as log base 5 of the quantity z squared plus 1 all raised to the 3rd power plus log base 5 of y to the 5/3 power. Remember, we have a minus out front, so we can distribute that in front of both of these logarithms. Next, log base 5 of 5 is a special case of the inverse rule from the last problem. This case is usually referred to as the identity rule. Essentially, log base a of itself is equal to 1. Similarly, log base 5 of 5 would equal 1, and so we can replace it with 1. For all other logarithms, we use the power rule to bring the powers out front. 1/2 comes out front here, 3 comes out front here, and 5/3 comes out front here. Now, let's look at the -3 log base 5 of z squared plus 1. Is everything on the inside grouped together and raised to the same power? Well, no. So we can't do anything with this second power here attached to the z. So sometimes the power may not be able to be brought out front using the power rule. After checking that out, I see nowhere else I could use a logarithmic rule to expand a logarithm. Hopefully, after seeing an assortment of problems of different difficulties, you feel a little more comfortable expanding logarithms using these rules. If you found this content helpful, consider subscribing, commenting, or liking the video to support my channel. I'm Joe, and thanks for spending some time with me.